In this video, we will learn about relation and function. In mathematics, a relation is a set of ordered pairs, such that set A with the elements 1, -5, 3, -3, 5, 1, and 3, 7 is a relation. And the set B with the elements -3, 2, -1, 0, 1, 4, and 5, 3 is also a relation. The domain of a relation is the set of the x values of ordered pairs in a relation. Let's say we're given the same set or relation A and the same set or relation B. In writing the domain, it is recommended that we arrange the elements in order, and there is no need to repeat the same elements. For example, the domain of the relation A consists of the numbers 1, 3, 5, and 3. So those are the x values. But we need not repeat the same elements. Therefore, we only have 1, 3, and 5. So the domain of A is the set of the numbers 1, 3, and 5. Next, the domain of the set B or relation B consists of -3, -1, 1, and 5. So those are the x values. Therefore, again, the domain of B is the set of -3, -1, 1, and 5. The range of a relation is the set of the y values of the ordered pairs in a relation. Let's say we are given the same set A or relation A and the same set or relation B. In writing the range, it is also recommended that we arrange the elements in order. And again, we need not repeat the same elements. For example, the range of the relation A above consists of the numbers -5, -3, 1, and 7. So those are the y values. Therefore, the range of A is the set of -5, -3, 1, and 7. Now, the range of the relation B consists of 2, 0, 4, and 3. So again, we have to arrange the elements in order. Therefore, the range of B is the set of 0, 2, 3, and 4. Now, what is a function? A function is a set of ordered pairs in which no two ordered pairs have the same x values. Therefore, a function is a relation because again, it is a set of ordered pairs in which the x values are unique. For example, this set A is a relation because it is a set of these ordered pairs. But is it a function? Let's check the x values. So we have here 1, 3, 5, and 3. Now, since there are two 3's, or the number 3 is repeated, the x values are not unique. Therefore, this set A is not a function. So A is a relation, but it is not a function. How about the set B? Okay, the set B is a relation because it is a set of ordered pairs. Okay, but is it a function? Let's check the x values. So we have -3, -1, 1, and 5. Since the x values are unique or different, set B is also a function. Therefore, B is a relation and a function. So we have to remember something about relation and function. And that is, all functions are relation, but not all relations are function. Again, all functions are relations since a function is a special type of relation, but not all relations are function. This time, what if we are given a graph? How do we determine whether the graph represents a function? We can perform the vertical line test. Again, this test is used to determine whether a given graph represents a function. To perform a vertical line test, we simply draw a vertical line anywhere on the graph. If any vertical line has one point of intersection with the graph represents a function. But if any vertical line has two or more points of intersection with the graph does not represent a function. Let's consider an example on how to perform the vertical line test. Let's say we are given this line that is leaning to the right. If we draw a vertical line to the left of the y-axis, we have a single point of intersection. If we draw another vertical line to the right of the y-axis, we also have a single point of intersection. Therefore, since for any vertical line there is only one point of intersection with the graph represents a function. Next, let's say we have this line that is leaning to the left. If we draw this vertical line to the left of the y-axis, we have a single point of intersection. If we draw another vertical line to the right of the y-axis, we have a single point of intersection. Therefore, this graph represents a function. Next, what if we have a curve like this one? Okay, if we draw a vertical line to the left of the y-axis, we can have this point of intersection. So we only have a single point of intersection. But if we draw a vertical line to the right of the y-axis, we have two points of intersection. Okay, therefore, since this vertical line, has 2 points of intersection with the graph, this graph does not represent a function. Lastly, what if we have this curve? Okay, if we draw a vertical line to the left of the y-axis, we have a single point of intersection. If we draw another line to the right of the y-axis, we have a single point of intersection. In fact, for any vertical line that we draw on this graph, we will get a single point of intersection. Therefore, this graph or this curve represents a function. If you have any question, please leave a comment.